Hello, this is Ollie Wu. I'm back with yet another video tutorial. And again, today it is about cloning saturation plugins. Now, last time we did it manually by sending a sine tone into the plugin and looking at the spectrum. Now, you might have heard that there's also something like the neural amp modeler or the Proteus plugin, or even ToneX from IK Multimedia. And what all these plugins have in common is that they're using a neural network to mimic and model the saturation behavior. There's also plugins like this one that are modeled after, say, a given preamp. The problem I have is that they're using way too much CPU still, and oftentimes they're in mono. So they're working quite fine for for the guitar or bass amp case. But really, this one is using like 40% of the CPU on this admittedly a bit slow laptop, whereas a reverb might just use 5 to 10% on the same machine. So instead, there is a brand new plugin from Aspen Instruments. It's still in beta, but we're going to give it a try. And it's a combination of two plugins. One is to playback distortion. And you can see it's using some kind of transfer function here. And the other one is called Black Diamond Probe. So Black Diamond Distortion and Black Diamond Probe is the one to record also. And you might have seen a similar transfer function in other plugins. But I can tell you that trying to edit this transfer function by hand is also a bit tricky and not easy. So I'm quite glad they have a recording plugin for this now. So let's look a bit into how that is working. Okay, so I've set up the typical structure for my project with a browser right here. And you know the structure by now: tone generator, plugin under test, the cloning plugin, and an analyzer. Well, we will this time use a Melda oscillator plugin. This one is a bit different from the last one. So far we were using pink or white noise. This time we're starting out with a 100 Hertz sine wave, so very similar to what we were using in Plugin Doctor in the last tutorial. We will then add a plugin here, and we had a bit problems to find a good clone for a transistor preamp. So let's use that as an example this time. And I will add my probe plugin into the same channel. And we get to that in a minute. And we will then finally put that distortion plugin here into the comparison channel. We get back to that in a minute as well. And I am newly introducing a brand new free plugin that is called G-Fractor. And it's yet another spectrum analyzer, and we'll use that this time around. And you notice that I already set one channel to left and one to right. Now the analyzer can also use the sidechain, but it's not yet putting the sidechain on top of the left and right input. So I'm going to use just one channel left and one channel right. Okay, and then we're doing the usual connection. We're sending our signal to saturator 1 and saturator 2. Make sure we're putting this on 0 decibels. And then we're sending this to our analyzer plugin. So here's the one side of it in green. And there's another analyzer, which is the other side, which is the right channel, which is, I believe, orange. Pulling that up a bit, somewhere around there, 50 or 55. Yeah, okay, so let's look in the black channel probe here. Now, one thing that is important when you plug it in, it will show sidechain is disconnected. So we have to make sure the sidechain is connected to that same signal generator right here. And the main plugin comes through this here, this distortion. And then you want to play around a bit with this setting here. Alternatively, you can also play around with the frequency and make sure that that fits. But if, 100 works here, all you want to make sure is that you don't have what they call a loop like this, but it's fairly overlapping. So if you can do that with the lag operator, that's fine. The other thing I want to do is I want to get it a bit more into the middle. And of course, you want to see some distortion. So we want to see a bit here, not just like a diagonal line. So I think somewhere around here is pretty good. So this is pausing it, this is playing. So once you recorded this, you can pause and you can save it. I'll replace this. And then I can load this into the plugin over here. UAD NIF preamp, this was a previous one. And say OK. So this is now the recording of the same signal. It might be a bit different in amplitude. And you can see it's not half bad. It might actually be a lot closer than we had it previously. Now this is now pretty much a stagnant signal. So what you can do is you can also record a neutral version of this. So basically without any saturation. You just have to make sure you get this also into this shape. And then I was recording this under the name neutral. So back in our other plugin, and this gets a bit complicated, there is now a way to scan things, to blend, doing series. But the easiest, I think, was to click on this and click on the folder and load neutral in one of them. And then click on the other one and load the one that you actually want, which is our video UAD NIF preamp. So now we have both of them and we can scan between them. And so this is maybe a bit too linear. Maybe you need to add a couple of more intermediate steps. We know they're not coming in linearly like this usually. You can see that the shape is changing. So, maybe I take a quick break and I record 3 or 4 different versions. Okay, now I recorded a version at 50 decibels, 55, 60, and 65. So if you only look at this, it's no longer linear. Things are going up and down, and not just the whole volume goes up for everything. So you can be as granular as you like, really, with this. Very nice. So this is definitely a lot closer than we've come last time. All right, that's it for today. This is Ollie Wu. See you next time.